Hey guys, this is Professor Janacek. I want to go over the vector operation of cross product. Let's start with two non-zero vectors, u and v. These are in 3 space. And let's say that the angle between them is theta, where theta is between 0 and pi. So the cross product of u with v, so u cross v, is the determinant of the vector, of the matrix that's created with the coordinate unit vectors I, j, and k as the first row, the components of u for the second row, and the components of v for the third row. Now make sure you remember what that looks like, how we determine this. This would be I times the determinant of u2, u3, v2, v3 minus minus j times the determinant of u1, u3, v1, v3 plus k times the determinant of u1, u2, v1, v2, which of course we can take that one step further. This would end up being u2, v3 minus u3, v2 times I minus let me put that in the back, u1, v3 minus u3, v1 times j plus u1, v2 minus u2, v1 times k. Don't try to memorize this here at the last bit. Just make sure you remember how to build it. It's much easier that way. Remember how to find the determinant of a matrix rather than memorizing this formula. All right, so the magnitude of this, it turns out, is the magnitude of u times the magnitude of v times the sine of the angle. Now, I want to point out that this is a vector. It's a vector value, not a scalar value. So it has both magnitude and direction. The direction of this, we can use what's called the right-hand rule. So we'll start by placing our vectors tail to tail, and then we'll place our right hand along u, wherever the u vector is. Then we curl our fingers towards v. If you have to change the positioning of your hand to do that, then go ahead. Just make sure you have your hand on u, but you can curl it towards v. Then wherever your thumb is, that is the direction of u cross v. Turns out that if u cross v is 0, notice that's the 0 vector, not the 0 scalar. If u cross v is the 0 vector, then the direction is undefined. We know that two vectors are parallel if their cross product is the 0 vector. And if two vectors form the sides of a parallelogram, then the area of the parallelogram turns out to be the scalar value u of u cross v, the magnitude of u cross v. So again, you've got two vectors that form a parallelogram. There's our two vectors that form a parallelogram. Then we want to find the area of that parallelogram. We find the magnitude of their cross product. Also notice that we cannot commute the cross product. U cross V is not equal to v cross u, because that means we would have to change the order of our matrix. So make note of that. There is a nice application for cross product, and that is dealing with torque. If F is the force applied at a point P, and that's at the, notice P is at the head of a vector, we'll call it R. You can also call R the vector OP. So P is the head, O is the tail. Then we have the torque, which we use the Greek letter tau to denote. Tau looks a lot like the Greek letter pi, but with only one leg instead of two. Also known as the twisting effect. That is, this torque, notice, is the twisting effect at point O. So remember, R is the vector from O to P. O, it starts at O and goes to P. So I've got this force at P. What happens at O? Well, tau is the cross product of R and F. Of course, the magnitude of that is the magnitude of tau times the magnitude of F times the sine of the angle between them. And so make sure you understand what's going on here. So again, we have, we started with point P. Here's point P. And we have this force being applied at point P. What we're looking at is what's going on up here at O, right? What's happening up there? Well, that is this torque. That is tau. And if we look at the direction of this torque, now we know how to calculate the magnitude of that torque. There's the magnitude of it. But if I want to find the direction of it, remember the right-hand rule. I would place my hand along this vector OP, which is vector R. Notice my fingertips would be over here toward P, and then I would curl those fingertips toward the other vector F. So curl your fingers towards F. And notice what would happen in this case is that the direction would be that your thumb would actually be coming out of the page. Coming toward you, so out the front of the page. And there you go. Nice little application for cross products. Enjoy.